except for you're going to come up with your own half reactions. We are not going to be using the data booklet for this. Data booklet is one way you can do this. There's another way that you can do this, writing out half reactions, and it's going to be up to you guys to come up with these half reactions. So the first thing you're going to do here today is you're going to divide the equation. So I'm going to give you an equation, and you're going to divide it into two half reactions, because in the equation, something has to be reduced and something has to be oxidized, of course. Okay? One for oxidation, and of course the other one's going to be for reduction. You will then balance elements other than H and O. Okay, so you're going to balance, like, for example, sulfurs, or maybe chromiums is a pretty common one. Things like that. You're going to balance those elements first, and you're going to pick those out of the equation. Okay, you're going to write out reactions. You're going to balance them based on that. And then after that, you're going to balance the oxygen atoms by adding waters. Okay, because these, in order to get ions, quite often we need water as a solution. Okay. So we're going to balance the oxygens. Then, after that, okay, we will finally balance the hydrogens by adding H plus as needed. Then you will balance, of course, the charges by adding electrons as well. Okay, so at the end, we need to come up, remember, what does reduction and oxidation half reactions always involve? Well, reduction gains electrons. Where are those electrons coming from? The oxidation half reaction. So we have to balance out those electrons as always. That's what we've always been doing here. So here we go. Balance the electrons and add the two balanced half reactions to get together to get the balanced redox, and simplify it if necessary. So in other words, canceling out, like I showed you on that second example there, homework yesterday, we had to cancel out waters and things like that. We'll have to do that today as well. Okay, so here we go. The first one here says balance out the following reaction at acidic conditions. And this is what we have here. Okay, so let's do this. So, first things we're going to do here. Let me just write this out here real quickly. S8, so I can see it. And, what was it here? NO3 minus. And, what do we got? SO2. And NO. Okay, so we're going to take out and basically divide this into two half reactions first. So first of all, okay, this is kind of my target equation here, right? So this is kind of what I'm looking at here. On this side, I have an S8. So I have sulfur on this side, and we have to match it up with something on the right-hand side, probably SO2. Okay, so that's what I'm going to start with. I'm going to start with an S8 on the left-hand side. And on this side here, I'm going to have my SO2 gas. Okay? So I write that part out first. Yes? Okay? So sulfur matches up to the sulfur one. I'm going to balance atoms that are not oxygens or hydrogens. Okay, I don't want to balance those. So I got 8 sulfurs here. I need to have 8 sulfurs there. Okay? Good so far? Now, after that is taken care of, now I'm going to balance oxygens by adding waters, because this solution, these probably take place in a solution type of setting. Well, let's see. I have 16 oxygens, correct? If I want to add water, I would add water to this side here. I'm going to add 16 waters. Okay? I balance oxygens by adding waters. 16 O's, 16 O's. Yes? Okay, don't worry about the H's. That's not part of this right now. 16 O's here, 16 O's here. I have 16 O's on that side. I need 16 O's on this side. Yes? So I add 16 waters. Now, it says it's under acidic conditions. Acids mean what? H plus. How many H's do I have on this side? 32. So I'm going to add 32 H pluses on this side. Okay? Because remember, okay, if I have 16 O's, well, 32 H's, I'm going to add 32 H's on that side. Okay? Now, is all the atoms balanced so far? Are all the atoms balanced? Yes or no? 8 sulfurs, 8 sulfurs. 16 O's, 16 O's. 32 H's, 32 H's. Yes? Okay. The last thing I need to do is I need to add some electrons, because is the left side equal to the right side as far as charges go? No. Okay. What's my charge on this side here altogether? 0, right? 0, 0, right? 0, 32 positive, and I need to add some electrons, yes? So I'd add 32 negatives to that side there. Correct? So the left side equals the right side as far as charges go, yes? Okay? Yes? No? Okay. What is this? Is this a reduction half reaction or an oxidation half reaction? You better know the answer by now. Oxidation. Because electrons are on the product side, right? They're being given off. In fact, given off 32. So that's my oxidation half reaction. I guess by default then, my next one better be the reduction. And if it's not, something's horribly wrong. Something's messed up somewhere. Okay? Well, what else do we have? Well, we took care of these two things here, right? Those are done. So let's take a look at this one and this one here. I got NO3 minus and I got NO. So let's write those down. NO3 minus. And over on this side here, I got my NO gas. Okay? And once again, you'll notice arrows lined up, nice and neat, left side versus right side. Okay? Now, let's balance the atoms that are not oxygen. So N, N, good, right? Yes? I got 3 O's here. I got 1 O there. So how do I balance O's? I add what? Waters. I'm going to add 2 to this side, correct? Because that'll give me 2 O's, and 1 O is 3 O's, and there's 3 O's there. Yes? And because I've added 4 hydrogens on that side, I'm going to add 4 hydrogens on this side. Okay? Aqueous. All right? Left side has to equal right side. It does so far for all the atoms. Now I need to make sure the charges balance out. So look, 0, 0, yes? 1 minus and 4 plus. Overall, 1 minus and 4 plus, of course, is a 3 plus, yes? So I should add 3 electrons to this side here. Okay? Add up the charges, right? 1 minus, 3 minus, 4 plus, 0, 0 on the other side. And obviously the electrons should go on this side. If they don't, then you know you've done something wrong. Now you've gotten the oxidation and reduction half reactions. Now you will balance them. Lost 32, gain 3. What's the lowest common multiple of 3 and 32? $96. Yes? Yeah. So, times this by 32. I don't think there's anything else, right? Times this by 3. 64 would be your next option. That's not, 3 doesn't go into 64 evenly. Right? So then 96 after that. All right, add them up. Now, you will get stuff that cancels here. Okay? So, I'll give you 2 options here, guys. Listen closely. Look, as you're going through here, look, there's water here on the left side. There's water on the right side, correct? So you're going to be able to cancel some of those. There's H pluses here and there's H pluses there. You can cancel those as well. However, if you mess this up, in other words, if you can't do that, canceling, by looking at that stuff, then don't do that. Write it all out. Take 1 extra step, write it all out, and then go back and cancel out stuff. Okay? So, I'll tell you right now, I'm going to do a left side versus right side thing here. So, we got 3 times S8. I'm going to write it all out the first time here. And 48 waters. Okay? That's those 2 things there. Down here, I got 32 NO3 minuses. And 32 times 4 is what? 128? Yeah? Is that right? Somebody? H pluses. Yes? 4 times 32? Yes? No? Okay. On this side here, so that's my left side. That's all my left side. That's just this stuff. I got 24 SO2s. I have 3 times 32 is, what did we say? 96, right? H pluses. We got, what else do we got here? 32 NOs and 64 waters. Okay? Left side equals right side. What I did is I just multiplied all that stuff out on the left side, multiplied it all on the right side, and now I'm going to go back and cancel some stuff out. Yes? Okay? Now, if you can do that, because they're not all going to be times 3 and times 32, obviously. So if you can do that in your head or whatever, that's good for you. You know what? Usually I can't, because I'm not that smart. So I write it all out and then go back and cancel it. Because you know what? Ultimately, I usually get the right answer in most cases. Not always. All right? So let's take a look here. 3 S8s, that's good. No problem there. I got nothing to cancel with that. 32 NO3s, that's going to be golden too. On this side here, I got 24 SO2s. That's going to be good there. And I got 32 NOs, and that's good there as well. What I have in common on both sides is the hydrogens, so let's do that first. I got 128 here, I got 96 over there. So what's the net of those two? 32, correct? So I'm going to put 32 hydrogens on this side here. Okay. And next, of course, I have waters. I got 48 waters here, and I got 64 there. So the net result of that is what? 16, yes? 16 waters. And that's going to go over here, because remember, 64 on that side, 48 on this side. The net result is 16 on that side, yeah? I mean, you got 16 on the side that's got more, yes? You should be done, okay? And there's easy ways to check this when you're done. You know, I can, once again, this is kind of like the other day. You can check this and make sure it's right? Just like you checked those today. Let's see, 24 sulfurs, 24 sulfurs. 32 Ns, 32 Ns. Now, here's where it gets a little complex. 32 H's, 32 H's. 16 O's and 32 is 48. And another 48 is 96 O's and 96 O's. Check. 32 negative, 32 positive, 0. Combining those two together. 0, 0, 0. Done. Good. That's right. Check mark. Yada, yada, yada. Okay? All right. Once again, you could talk about, what are some observations here? Well, very conductive, not conductive, right? Very acidic, very neutral. pH goes up. Solid disappears. Gases form, bubbles appear. Okay? And you could talk about all that stuff again as well. All right? Good? All right. Let's take a look at another one. All right. So, this one here. And I believe this one's in acidic conditions as well, right? Now, this one here says MnO4 goes to C2O4. And if you look at this, guys, once again, oxygens, okay, they're this kind of going to be the same on both sides. We're going to talk about something called oxidation numbers later down the road. Oxygens don't change, okay? What are some of the other things that you see besides oxygen? Well, the MnO4, going to write that one down, goes to Mn2O4. 2 plus. Okay? So that's where I'm going to start. I say I got 1 Mn here, I got 1 Mn there, so I'm good. I got 4 O's here, I need to have 4 O's on this side. I got, alright, so I got 4 O's on the right side, okay? So 4 O's here, 4 O's there. I got 8 H's there, so I'm going to add 8 H's here. Okay? And then you're going to take a break here after doing all that, and you're going to say, okay, I need to add some electrons. Where do I add them? Well, let's see here. Altogether here, you have a 7 plus on the left-hand side, and on the right-hand side, you got 2 plus, right? 8 plus, 7 plus. Yes? 2 plus. I'm going to add 5 here. This is obviously my reduction, therefore. My oxidation will come next. Okay? Add up the left side versus right side, guys. 1 minus, 5 minus, that's 6 minus, and an 8 plus, that's a 2 plus, and on the right side I got 2 plus. What else do I have here? Well, I got C2O4, 2 minus, and that needs to go to CO2 gas. Okay? Balance the atoms first. So 2 carbons, 2 carbons. Balance the oxygens by adding waters. Well, 4 O's, 4 O's. Am I good? Yeah, don't need to. Okay? What about, do I need to add any hydrogens then? No, because I didn't add any waters, right? That's it, you're done. Is the left side balanced with the right side? Well, close. 2 carbons, 2 carbons, 4 oxygens, 4 oxygens. I don't need to add waters or hydrogens. The last thing I do need to do, though, is how did C2O4 2 minus become 2 CO2s? Well, electrons are involved, right? So I got a 2 minus here. I'm going to add a 2 minus here. Left side has to equal the right side, right? So 2 minus, 2 minus. Good. Add them up. And that'll be your redox. So before we add them up, let's see. 5 electrons, 2 electrons. So times 5 times 2, right? Lowest common multiple of 5 and 2. So 5 times 2, times 5 times 2. Now, we're not going to be able to cancel a whole lot of stuff because we didn't add any waters or hydrogens in the second one. So we might just get lucky here and might just have to write all this stuff out. 16 H pluses. We got 5 C2O4 2 minuses. And I think this was aqueous here. Must have been probably. Yeah. Let's see. On the right side, I got 2 Mn2 positives, 8 waters, and 10 carbon dioxide gases. Okay? And you're done now. Let's double check. You know, sometimes when you go through and you're multiplying stuff, you miss a number here or there, and you don't multiply it. So sometimes that happens. Let's double check. 2 Mns, 2 Mns. Let's see. 16 H's, 16 H's. I got 10 carbons, 10 carbons. Let's add up some oxygens here. That's 8 and 20, so 28. I got 20 and 8, that's 28. Let's do charges real quick. 2 minus, 10 minus, so that's 12 minus, and 16 positive is a 4 positive, and there's a 4 positive there, so it looks good. Once again, you could go through and write down observations for this. Very conductive here, not very conductive there. Permanganate ion has a color that goes with it, so you could talk about that. Manganese, I believe, has a color that goes with it. I'd have to double check that one. Very acidic, neutral. Okay, pH goes up. What else? Bubbles would form. No solids are being used up here, produced, but all that stuff. Okay? Good? Yes? One more example. We're going to switch it a little bit on you. Make it a little bit tougher. Not tougher, a little bit more work for you, if that's not enough. Okay? If the reaction is taking place under basic conditions, you need to add enough hydroxide to cancel out the H pluses that you've added. So in a few of those examples, we added, of course, water. You know, the first one we added 16 waters, remember? Which gives us 32 H pluses. Well, if I don't do anything about that, 32 H pluses is very acidic. How do I cancel out 32 H pluses? I add 32 OH minuses, because H plus and OH gives you water, neutralized. But if I add 32 hydroxides on one side, it's not going to balance out with the right side, so I got to do that as well. Okay, so here we go. The H plus and the OH combine together to form water liquid. Then simplify the number of waters, of course, in the redox equation. And here's our first example here. Okay, or actually our only last example here, by the way. So here we go. Same as before, guys. You start in the exact same place. Okay, so our last example here. Well, let's see. When I look at this equation here, I see a bunch of O's. That's not going to help me. Let's start with some Mn and Mn on the other side as well. Okay, so I'm going to start with, let's say, MnO4 minus, and on this side here, I got MnO2 aqueous. Okay, right? Okay, do you agree that's where we should start? Yes? Right. Balance the Mn's, did that. Balance the oxygens by adding water. I need to add 2 waters to this side. Okay, so I got the O's balanced. I added 4 hydrogens to the right side, so I need to add 4 hydrogens to the left side. However, that's great. We'd actually be done right now, and you guys already probably, if you can do that, you know how to do acidic conditions, except for adding the electrons. This is under basic conditions, and right now I have acidic conditions. How do I get rid of H plus? I have to add an equal number of OH minus. So I'm going to add 4 hydroxides to cancel out these 4 H pluses. Yes? Okay. But if I add 4 hydroxides to the left side, does the left side equal the right side now? It did until I added those, right? Without this, look, oh, this is where I wish, you know, we had, anyway, what old whiteboards? No, that doesn't work yet. Anyway, it was balanced, and then I added this, yeah? Now it's not balanced. So now it's balanced again, okay? So if I add 4 hydroxides to the left side to balance out the hydrogen ions, I need to add 4 hydroxides to the right side. Now, adding these up. Why? Look, this is a 1 minus right here. 4 plus, 4 minus, that's the purpose of adding those to cancel out the H pluses. That's neutral right here, okay? So 1 minus, and over here I got a 4 minus. So I'm going to add 3 minus to the left side here. Right there. Okay? Obviously, leave yourself lots of room when you do these. Okay? This is therefore my reduction half reaction, my oxidation half reaction, and you can clean that up a little bit if you want. So you could, we'll talk about that in a second here. You can go and do that right now if you want, but you know, whatever. I kind of like to just kind of take one step at a time here. It takes a little bit longer, but at least I know I'm doing them right. I guess the Cn minus going to CnO minus would probably be the next one I need to worry about. Okay? Once again, we'll add some waters. Let's add some to the left side. I kind of wanted you guys to do some of these on your own. Unfortunately, I don't think we're going to have enough time. That's why I didn't really have let you guys do any of these on your own here. I guess you'll get a chance when it comes homework time. So CN's balanced. We got an O on the right side. We add an O on the left side. I have two H's there, so I need to add two H's here. Okay, that's exactly what we've done in the past, so that would be balanced now if we're under acidic conditions. You'd add some electrons, you'd be done. We're under basic conditions, so I want to get rid of those two hydrogens, and I want to put in some hydroxides to cancel that out. Well, I also need to do that over here as well. Okay? Adding up these, you'll see on the left-hand side we got 3 minus, right? So 3 minus there. On the right-hand side we got 0 with the H plus and the OH minus. We got a 1 minus. So 3 minus here, I need to add 2 more to get 3 minus on that side. Okay? Now remember, if you go to, when you're doing this, if you don't have electrons on the left side and right side, if you get them both on the same side, something's not right. Okay, I'll save you the trouble right now. Obviously, because we have to equal electrons lost, electrons gained. Redox becomes a nightmare because you're going to have waters in a few spots. You're going to have to multiply both sides, and you're going to have to kind of simplify. Okay, and like I said, it can be kind of tricky. Before we get to redox, we got to balance out electrons. Don't forget, 3 electrons here, so I'm going to take that times 2. And 2 electrons here, so I'm going to take that times 3. And I'm simply going to try and kind of write all this stuff out and then simplify it. Okay? I will take a few shortcuts, but let's start here. 2 MnO4 minuses. I'm going to put my arrow right here again. So that one's done. And you can even go through and kind of check them off as you go. Okay? I'm going to focus on the top part. Look, guys, 4 H pluses and 4 hydroxides gives me 4 waters, yes? Yeah? H plus and OH minus is water. So I got technically 4 H pluses, 4 OH minuses, that's 4 waters. 4 waters times 2 is actually 8 waters. Okay? Times the 2 over there. I don't have to worry about electrons because that was the purpose of multiplying it out. I'm going to go to the bottom part here because I'm going to stay on the left side. 3 Cn minuses and 3 waters and 6 hydroxides. Okay? Now normally I just write this out in one big long line, but smart boards aren't that wide. Okay? These almost, usually what we like to do is just kind of do, you can either write them straight across and then put an arrow and then show me the next part, whatever, I don't care. I like to kind of keep it left versus right because that way everything's kind of lined up still. So I kind of like that. I used to just do these on the board because it was just easier. There's more space. Right? 2 MnO2s, 4 waters, 8 hydroxides, 3 times CNO minus. Oops. Let's try that again. 3 CNO minus. 2 H pluses and 2 hydroxides gives me 2 waters times 3 is 6 waters. Okay? So, I got left side versus right side. I'll tell you the stuff that you need to be careful of canceling. Okay? It is basically anything you've added to this equation. It has the potential to be canceled. Anything from the original equation probably is not going to get canceled because it was part of the original equation. Okay? That's what we were trying to figure out. So, the 2 MnO4 is probably legit. It's probably not going to get canceled out. When I look at this, I probably think 3 Cn minuses was part of the original equation. That's not going to get canceled out. Okay? Not saying it couldn't, but it's more than likely it's not going to. Okay? It probably won't. I would say not. Look, I got 11 waters here. Okay? You can even add them up if you want, kind of thing. That just happened to work out for me. 11 total there. How many do I got on this side? I got 4 and 6 waters. So 11 waters on the left side, 10 on the right side. So that's a net of 1 on this side. Okay? And once again, if you want to kind of go through here and check stuff off, that you've done. Okay, not a bad idea. Yeah. Three times, this was 2 right here, altogether, times 3. Okay. Hydroxides would come next. Look, I got 6 here, I got 8 there. So that's a net of 2 on the right side. I'm going to check those off. And then, don't forget though, I need to write them over here somewhere. Okay. So that takes care of all the left side is done. 6 hydroxides, 8 on the right side. So that's a net of 2 on the right side. Okay. But everything that on the left-hand side is taken care of. What else do I have? 2 MnO2s here. That's not going to cancel. And 3 CNO minuses. And that's not going to cancel. That and that. Looks like we've taken care of everything because I checked everything off. Okay. Let's take a look here. We'll find out pretty quickly. 2 MNs, 2 MNs. 3 CNs, 3 CNs. Now, oxygens. 8, 9, 4, and 3 is 7, 8, 9. Good. Hydrogens. 2, 2. Good. Charges. 2 minus, 3 minus, that's 5 minus. 3 minus and 2 minus, 5 minus. Good. Okay. So, lots of work there, obviously. Those are how you guys are going to come up with the reduction half reactions, not from the booklet. Okay. Now, we're kind of showing you basically what we're going to do over the next little bit here. We're showing you different ways of doing the same thing. Okay. So, could you do this from the data booklet is the question. And the answer is not always. Sometimes yes, not always. The question becomes, can you find these things on the left-hand side versus the right-hand side? And I'm not going to lie to you, some, yes, you can. And if that's the case, you may want to consider what we did for homework. Yes, well, let me rephrase that. What some of you did for homework the other day, okay? The 6 questions I gave you are all based on the data booklet. That can work if the reactions are there and they're exactly what you need to have. That's not always going to be there though. Okay? This one works all the time, but you do have to understand acidic versus basic conditions as well. And sometimes they won't tell you that in the question. Okay? So, those are all things that, like I said, that you need to be able to do there. Okay? Any questions on that, guys?